Hello, my name is Mary Kanai. This is my final project for Professor Weller's cis9467 class. I'm interested to open a Japanese bento store because Japanese bento is not only healthy, delicious, but also beautiful. In my project, I will use the Excel solver to determine how many bento to produce to maximize the profit. Mary's Japanese bento store provides seafood, meat, and vegetarian bento. The profit is comprised of sum of profit per bento times number of bento to be made. I want to maximize profit by changing the number of bento to make. There are several constraints. The bento should be whole number. Also, the total label used in hours should not greater than label availability. The number to be made must meet minimum demand to keep customer happy. In the meantime, must not exceed maximum demand. Now you can see the solver set the objective as the total profit to maximize the total profit by changing the variable sales of the number to make. So also I put the three constraints here, minimum, maximum, and the bento should be whole number. So now let's see what's the result could be. Now we can see the number to make all come to the number as maximized demand. It makes sense because we make more and sell more. We have more profit. However, total label used cannot access label availability. Now I add the constraint. The label used should be smaller than label availability. Now let's see the result. After add this constraint, the salmon bento, which has the highest profit per bento, decreased from 240 to 189 because it cost more time. The bento for children, which has the lowest profit, still keep the maximum demand because it costs less money. Some information for the monthly financial statement is based on this result, such as average price per unit, unit sold, unit produced, and variable cost. Now let's see the income statement analysis. This worksheet showed the income statement break-even analysis chart, plotting break-even points and the formulas. The formula shows that the break-even unit is equal to fixed cost divided by sales price minus variable cost. From this formula, you can see here the H3 is fixed cost. B4 is sales price, B10 is variable cost. The graph also showed the break-even sales amount is 5,000, more than 5,000. Also, here is the same number here. I created dynamic break-even chart. We can see if I increase the sales price from to $8, so we can see the amount decreased. So if I decrease the price to $7, so we can see the amount increased. So it can move around. If it's $9, it's decrease more. Now let's see what happens if I increase the variable cost from $5 to $6. Now we can see the amount increased. So if I decrease to $4, so the amount decreased. That means that if the variable cost decrease, we need to sell less products to break even. Now I will use go-seek function to show break-even point in different scenarios. Go to go-seek. So the net income value to 0. So by change the seed, I want to see the sales price. So we can see the break-even sales price changed from $7.02 to $6.02. Let's see if I cannot change the sales price, how many units I need to produce to break even. So I go to a go-seek. Again, set the amount value to 0, then go to units produced. So we get units break-even amount. Cost per units is something we can control. So if we want to make profits, let's see so see the cost per units. So if we want to make profits, so the cost per units cannot bigger than $5.09. I like break-even chart analysis. It's more dynamic and easy to show the trend. I also like go-seek analysis. It could give you more details. I used the macro function which I learned from Professor Wheeler's class to create a return button. I'm glad Professor Wheeler gave us the chance to do the project. I also appreciate people who share their YouTube videos. In order to do this project, I watched many YouTube videos. Thank you for watching my project.